Hello and welcome to Sleepy Food. In this video, we will explore the complete life cycle and transformation of one of the world's most familiar fruits, the tomato. This narration is intentionally slow, detailed, and repetitive. It is designed to help you relax, focus, or fall asleep. There will be no sudden sounds, no music, and no emotional tone. Only the steady voice of information. Now please sit back, close your eyes if you like, and let the story of the tomato begin. The tomato is a fruit that has travelled far both in space and in time. Its story is not just biological, but cultural, ecological, and agricultural. It begins quietly in the soil, but stretches outward into gardens, markets, kitchens, and plates across the globe. Though often taken for granted, the tomato carries within its skin and seeds a long and intricate journey, one shaped by centuries of evolution, selection, and culinary imagination. It is a fruit, born of the sun, ripened by warmth, and made useful through careful human attention. Its red colour, its soft flesh, and its rich flavour are the final result of thousands of small steps that happen almost invisibly each day from the moment the seed is pressed into the earth. But before it became a staple on pasta dishes, sandwiches, salads, and sauces, the tomato was an unfamiliar plant, growing wild in the Andes, with small yellow fruits, not much larger than a berry. Indigenous peoples of South America were the first to cultivate and consume this plant, recognizing its potential and domesticating it through generations of selection. Later, the tomato made its way to Mesoamerica, where it became part of the diet long before European contact. When Spanish explorers arrived in the Americas, they brought the tomato back across the Atlantic, where it was first met with hesitation and suspicion. In parts of Europe, it was viewed as poisonous, a member of the nightshade family, and perhaps too strange for the kitchen. Yet over time, as knowledge and curiosity spread, the tomato found its place in Mediterranean gardens, and then in Mediterranean cuisine. In Italy, it became inseparable from olive oil, garlic, and basil. In Spain, it was crushed into gazpacho and rubbed onto bread. In the Middle East, it joined lentils, rice, and herbs. In India, it mingled with spices. In America, it was sliced, placed between bread, and bottled as ketchup. The tomato became not just accepted, but beloved. Its journey from suspicion to celebration is itself a story worth remembering, and one that mirrors the way knowledge often grows slowly through observation, repetition, and trust. But before any of that, before the sauce and the slicing, there is the seed. And from that seed unfolds a complex cycle of growth, transformation, and renewal. The life cycle of a tomato begins in darkness, in stillness, in the soft, damp bed of soil, or in a prepared tray where seeds rest, waiting for warmth and water to awaken them. It continues upward through fragile stems and early leaves, branching into a network of green that seeks light and absorbs air. It flowers not for beauty, but for reproduction, forming delicate yellow blooms that attract bees, wind, and time. From those flowers, the fruit begins to swell, a green orb forming where once there was only a petal. The fruit grows slow, then faster, fed by roots and rain and care. It changes colour from pale to golden to red, or sometimes orange-pink or striped, depending on the variety. It ripens not just in taste, but in structure, becoming soft, fragrant, and full. And then it is picked, or falls, or is left behind. The tomato is eaten, sliced, stewed, canned, dried, or crushed. It is shared, it is tasted, it is used. Its seeds are sometimes saved and planted again. And so the cycle continues. This cycle is at once ordinary and extraordinary. It is a process repeated across fields and balconies, across continents and generations. It happens in commercial greenhouses, under artificial lights, and in backyard gardens, guided by the rhythm of the seasons. It is shaped by biology, but also by hands that water, prune, and harvest. It is affected by weather pests, nutrients, and time. And yet, despite all this complexity, the result is something familiar and comforting, a round red fruit that fits in the palm of a hand and in the center of a meal. This video is a slow, quiet exploration of that life cycle. Each section will follow a part of the tomato's journey, from seed to sprout, from flower to fruit, from vine to kitchen. There will be no excitement, only information. There will be no sudden turns, only gentle steps. The goal is not to entertain, but to soothe, to follow the story of a tomato as it quietly becomes itself. You will hear about seeds, roots, stems, leaves, flowers, and fruit. You will hear about sunlight, water, and time. You will hear about flavour, texture, and transformation. You will hear about waiting, watching, and harvesting. You will hear about source. But not yet. First, you must begin where all tomatoes begin, in the soil, in the quiet, in the dark. The story of the tomato is about patience and care. It is about small changes that lead to full ripeness. It is about a fruit that does not rush, but waits until it is ready. In that way, the tomato reminds us of the slow, gentle processes that shape not only food, but life itself. And so this is where we begin. Every tomato begins not with the fruit that is visible, but with a seed that is hidden. And within that seed lies not only the potential for a plant, but a story that stretches backward through centuries of selection, adaptation, and survival. The process of seed selection is both scientific and historical, and it involves choices that determine the flavour shape, texture, colour, and resilience of the tomatoes that will eventually be grown. It begins with the understanding that not all tomato seeds are the same. Some produce small, sweet cherry tomatoes, while others yield large, meaty beefsteak varieties. Some grow tall and sprawling, while others remain compact and bush-like. Some thrive in dry climates, others need humidity. These differences come from genetics, which are passed down from parent plants to their offspring. And these genetic traits can be selected, preserved, or changed over time. For most of human history, tomato seeds were saved by gardeners and farmers who chose the best fruits from their harvest, often based on taste, yield resistance, or appearance, and dried the seeds for the next planting season. This practice, known as open pollination, allowed tomatoes to slowly adapt to local soils, climates, and cultural preferences. Over generations, the result was a wide diversity of tomato varieties, each shaped by the people and places that cultivated them. Heirloom tomatoes are one example of this process. They are varieties that have been handed down for at least 50 years, often within families or communities, and they tend to have distinctive flavors, colors, and shapes. Their seeds can be saved and regrown without losing the characteristics of the parent plant, which means that the traits are stable across generations. These tomatoes might be striped purple, orange, or pink, and they often have irregular forms and complex flavors. They are valued not just for their taste, but for their connection to agricultural heritage. In contrast, modern commercial tomato seeds are often hybrids, created by deliberately crossing two different parent plants to produce offspring with specific traits such as disease, resistance, uniform size, or long shelf life. Hybrid seeds are useful for large-scale farming because they provide consistency and can be tailored to withstand transportation and storage. However, the seeds of hybrid tomatoes usually do not grow true, which means that saving and replanting them does not guarantee the same fruit in the next generation. This makes them less suitable for traditional seed saving and ties growers to seed suppliers for each planting cycle. In recent years, genetic research has gone further by identifying the specific genes responsible for traits like firmness, sweetness, acidity, or ripening time. Scientists can now map tomato genomes and even use gene editing tools to influence how tomatoes develop. This knowledge allows for more precise breeding, but also raises questions about biodiversity access and control over food sources. Whether by traditional selection or modern breeding, the decision about which seeds to plant affects the entire life cycle of the tomato. Seed catalogues are filled with names that reflect both biology and imagination. Some varieties are named after places such as San Marzano or Brandywine, while others are named for color size or novelty, like green zebra or big rainbow. Choosing a seed means choosing a future fruit, a future flavor, a future plant. Each seed is a genetic package, a collection of instructions encoded in DNA that tells the plant how to grow, how to respond to light and temperature, how to defend itself, how to produce flowers, and how to ripen. But it is not just genetics that shape the plant. The soil, water, care, and weather will all interact with the genes to create the final result. This interaction is called the environment, and it ensures that even identical seeds can produce different outcomes in different conditions. Saving seeds is also an act of preservation. Around the world, seed banks and local growers maintain libraries of tomato seeds to protect biodiversity and ensure that older varieties do not disappear. In a world where commercial agriculture often focuses on a narrow range of crops, these efforts help safeguard the genetic richness of tomatoes for future generations. In some communities, seed saving is a shared tradition, passed through stories, and hands a quiet resistance to uniformity and loss. It is an act of memory and hope, one that connects past harvests to future meals. Selecting a seed is choosing a path. It is the first gesture in a long, slow journey toward a tomato. It carries with it history, possibility, and care. Though the seed is small, its significance is vast. Inside its tiny shell are instructions shaped by centuries of cultivation, decisions made in fields and kitchens across the world. And from that tiny starting point, an entire plant will one day stretch toward the sun, offering its fruit in return for the care it has received. The process of germination is a quiet miracle, a transformation that begins within the hidden world of soil or seed trays, where light does not reach, and movement is almost imperceptible to the human eye. It starts when the dry, dormant tomato seed comes into contact with moisture, triggering a series of biochemical reactions that awaken the embryo within. This moment is not loud or dramatic. It is subtle and internal. Water enters the seed through the protective seed coat, softening it and activating enzymes that begin to break down stored starches into sugars, providing energy for the sleeping plant to wake. As moisture and warmth continue to penetrate the seed, a root, known as the radicle, emerges, first pressing downward in search of stability and nutrients. This first root anchors the seed into the soil and allows the seedling to begin absorbing water and minerals essential for further development. Shortly after the root establishes itself, the shoot begins to push upward toward the surface, carrying with it the cotyledons or seed leaves that serve as the plant's first source of photosynthesis. These small leaves are not true leaves, but temporary structures designed to sustain the seedling until its first set of real leaves emerge. The moment the sprout breaks through the soil is often celebrated by gardeners, yet it is only the visible sign of a much longer hidden process. This emergence is the plant's first interaction with light, a signal that triggers another wave of changes. The stem straightens and the seed leaves unfold, absorbing sunlight and continuing to convert it into energy through photosynthesis. At this stage, the tomato plant is fragile and highly sensitive to its environment. It requires warmth, but not heat, consistent moisture, but not saturation light, but not harsh, direct rays. Too much or too little of any of these can cause the seedling to wither or stretch unnaturally in search of better conditions. The stem thickens slowly and begins to support the plant's upward growth. At the same time, tiny root hairs begin to grow along the root system, expanding the plant's ability to absorb water and nutrients. These root hairs are extremely fine and numerous, creating a large surface area in contact with the soil. The success of these early days determines the plant's strength later in life. A tomato seedling that grows too quickly without enough light may become leggy thin and weak, making it vulnerable to wind pests or disease. On the other hand, a seedling grown slowly in stable conditions will develop a thick, sturdy stem and a balanced root system, able to support future growth. As the seedling continues to grow, it produces its first set of true leaves, which are distinctly different from the round, smooth cotyledons. These true leaves have the familiar shape and texture of tomato foliage, deeply lobed and slightly fuzzy. They mark the beginning of the plant's mature vegetative stage. This transition is not sudden, but gradual, a handoff from temporary structures to permanent organs that will carry the plant through the rest of its life. During this period, the seedling is often transplanted from its original tray or pot into a larger container or into the ground, depending on climate and growing method. This move must be done carefully to avoid damaging the roots or disturbing the delicate balance the young plant has achieved. Transplanting introduces the seedling to new soil, new microbes, and a different set of environmental conditions. If done successfully, it stimulates further root growth and strengthens the plant's resilience. It is during these early weeks that the foundation for the entire tomato plant is laid. The number of leaves, the thickness of the stem, the depth of the roots. All of these traits are established during this stage and influence how the plant will flower fruit and resist stress later on. The sprout may look small, but it is building the framework for a complex and productive organism. Germination and sprouting are ancient biological processes shared by countless plants across ecosystems and eras. Yet each seedling is also unique, shaped by its genetics and its environment. Watching a tomato sprout grow is a reminder that all complex systems begin simply with a small push, a small root, a small shoot. It is a reminder that time, patience, and care are required to bring even the most familiar foods into existence. The sprout does not hurry and it does not pause. It moves with quiet purpose, responding to light and gravity, moisture and warmth. And slowly over days and weeks, it becomes something more than it was. In the life cycle of the tomato, this is the moment when potential becomes visible, when the story shifts from seed to plant, and when the journey toward fruit begins in earnest. It is not yet a vine and not yet a flower, but it is alive and growing and reaching. As the tomato seedling grows above ground, it is easy to focus on the leaves, the stem, and the light. But below the surface, an equally important process is unfolding, one that is entirely hidden and yet foundational to everything that follows. The development of the root system is the plant's silent infrastructure, a network of threads and branches that provide support, hydration, nutrition, and communication with the environment. It begins with the primary root, which first emerged during germination, pushing downward into the soil. This root does not remain alone for long. It soon gives rise to secondary roots, which spread laterally in search of moisture and nutrients. These roots then branch further into even finer root hairs, which extend the root's reach into tiny spaces between soil particles. The purpose of this expansive network is to maximize contact with the surrounding medium to absorb water and minerals such as nitrogen, phosphorus, potassium, calcium, magnesium, and trace elements that are essential for plant growth. The root system is not static, but dynamic, responding constantly to soil conditions, water levels, temperature, and the presence of other organisms. When the upper soil dries, the roots may grow deeper in search of moisture. When nutrients are plentiful in one area, roots may grow more densely in that direction. The structure of the root system also helps anchor the plant physically. As the tomato seedling grows taller, the roots spread wider and deeper, balancing the visible and invisible parts of the plant. A strong root system provides stability, allowing the plant to resist wind and support the weight of its developing stems, leaves, and eventually fruits. In container gardening or transplanting situations, the roots often take on a slightly different pattern, growing in circles or adjusting to the shape of the container. Care must be taken to prevent root binding, where the roots grow so tightly in circles that they restrict the plant's ability to take up water and nutrients. Good soil structure is essential for healthy root development. Soil must be loose enough to allow air and water to move, but firm enough to hold the plant in place. Soil that is too compact can suffocate roots, while soil that is too loose may not provide enough support. Organic matter, such as compost, helps improve both structure and nutrient availability. In addition to physical support and nutrient uptake, roots also play a role in the plant's interactions with the surrounding microbial world. Tiny organisms, such as bacteria and fungi, live in the rhizosphere, the thin zone of soil that surrounds each root. Some of these microbes form symbiotic relationships with the tomato plant, such as mycorrhizal fungi, which extend the effective reach of the roots in exchange for sugars produced by the plant. These relationships help improve nutrient uptake, particularly phosphorus, and increase the plant's resistance to disease. The health of the root system is not only vital for early growth, but also influences the entire life cycle of the tomato. A plant with well-developed roots will be more productive, more resilient, and more efficient in its use of water and nutrients. This in turn affects flowering, fruiting, and the quality of the tomatoes produced. During early development, the plant's energy is focused on expanding this root system and producing a strong central stem. Leaf production increases, and each new leaf becomes larger, more complex, and more efficient at capturing sunlight. These leaves feed the root system through photosynthesis, while the roots support the leaves with water and minerals. This feedback loop creates a balanced growth pattern in which each part of the plant supports the others. Temperature and light also affect root development. Tomato roots grow best in warm soil, typically between 18 and 24 degrees Celsius. Cold soil can slow growth and reduce nutrient uptake, while overly hot soil can damage root tissues. Maintaining consistent soil moisture and temperature is crucial during this stage. Overwatering is one of the most common problems for young tomato plants. Excess water can create an oxygen-poor environment, leading to root rot and other fungal diseases. The roots need both moisture and air to function properly. Allowing the soil to dry slightly between waterings encourages roots to grow deeper and strengthens the plant's resilience. Observing the growth of the tomato plant during early development provides insight into the silent labor of the roots. While the upper part of the plant grows visibly taller and greener, the roots expand invisibly below, drawing nourishment from the earth. This duality of growth, one visible and one hidden, continues throughout the tomato's life. Together, they form a complete system, connected through vascular tissues that transport water, nutrients, and sugars from one end of the plant to the other. Understanding and supporting the development of the root system is an essential part of growing healthy, productive tomato plants. Though often overlooked, these roots perform the foundational work of life-transforming soil and water into fruit and flavor. Without them, the tomato would never rise above the surface, never flower, never fruit. It is in these early days that the groundwork is laid, both literally and figuratively. From a single root, a whole plant emerges. From the soil, life ascends. As the tomato plant continues its early development, above the soil, it begins to produce true leaves that differ from the simple seed leaves which first emerged during germination. These true leaves are more complex in shape and contain a greater number of cells dedicated to capturing sunlight through the process of photosynthesis. The creation of each new leaf marks another step in the plant's ability to sustain itself, drawing energy from the sun and transforming it into the sugars that fuel further growth. Photosynthesis is a quiet process that occurs within specialized structures in the cells called chloroplasts, which contain the green pigment chlorophyll. This pigment captures light energy and uses it to convert carbon dioxide from the air and water from the soil into glucose and oxygen. The glucose becomes food for the plant, while the oxygen is released into the air. This reaction powers the tomato plant's metabolism and is essential to every stage of its life, from stem elongation to flower development, and eventually fruit production. Leaf formation follows a distinct pattern, with new leaves emerging from the tip of the growing shoot, known as the apical meristem. This region is made of undifferentiated cells that divide rapidly to produce new tissues. As each leaf unfolds, it increases the plant's surface area for light absorption and enhances its ability to photosynthesize. The leaves of a tomato plant are compound, meaning each one is divided into multiple leaflets arranged along a central axis. These leaflets have serrated edges and a slightly fuzzy texture due to the presence of small hairs called trichomes, which help protect the plant from insects, dehydration, and excessive sunlight. The spacing and orientation of leaves on the stem are also important. Tomato plants are adapted to arrange their leaves in a way that reduces self-shading, so that each leaf has access to light. This pattern is known as phyllotaxy, and it ensures that the plant makes efficient use of available sunlight. The veins within each leaf form a branching network that delivers water and minerals from the roots to the leaf cells, while carrying sugars produced in photosynthesis to other parts of the plant. This vascular system is composed of xylem and phloem tissues, which function as internal highways connecting the leaves to the rest of the plant. As the plant grows, the number of leaves increases and their size expands. Each leaf begins small, tightly folded, and protected at the growing tip. As it matures, it elongates and spreads, becoming a functional organ of light capture and energy production. The health of the leaves can often be used to assess the overall condition of the plant. Yellowing or curling leaves may indicate nutrient deficiencies, water stress, or disease. Dark green vibrant leaves suggest that photosynthesis is proceeding efficiently and that the plant is receiving adequate light nutrients and care. Light quality also plays a role in leaf development. Tomato plants respond not just to the amount of light, but also to its spectrum. Blue light encourages compact growth and strong leaves, while red light promotes flowering and fruiting. In natural sunlight, both wavelengths are present in balance, but in controlled environments like greenhouses or indoor growing setups, the spectrum can be adjusted to influence growth patterns. Temperature and humidity also affect photosynthesis. The enzymatic reactions involved in the process work best within a specific temperature range, usually between 20 and 30 degrees Celsius. Too cold, and the reactions slow down; too hot, and they may be inhibited or cause damage to the cellular machinery. Maintaining optimal conditions allows the plant to produce energy efficiently and grow steadily. As the tomato plant grows taller, it sometimes begins to shade its lower leaves. In response, the plant may naturally shed older leaves that are no longer contributing significantly to photosynthesis. This shedding conserves resources and redirects energy to newer, more efficient leaves and to developing flowers and fruit. Pruning can assist in this process, helping to improve air circulation and light penetration. The development of each leaf is a step in the quiet symphony of growth, and photosynthesis is the engine that powers it all. Every day, the plant captures sunlight and turns it into life-building tissues, extending roots, forming buds, and slowly preparing to flower. Though invisible to the eye, photosynthesis is a constant background process, shaping the size, color, taste, and nutritional content of the fruit that will eventually emerge. Without the formation of healthy leaves and the steady rhythm of photosynthesis, the tomato plant could not progress toward its final goal. In this way, each leaf is more than decoration. It is a factory, a sensor, a shield, and a messenger. It is where sunlight becomes substance, and where air and water combine to make food. It is where the invisible work of the plant becomes tangible, and where growth begins in earnest. And so the tomato plant reaches upward, one leaf at a time, toward the light that will feed it, shape it, and carry it forward on its journey from seed to source. As the tomato plant matures and continues to generate leaves and strengthen its stem, it approaches a quiet but critical stage in its development, which is flowering. This phase marks the beginning of reproduction, when the plant prepares to transition from vegetative growth to fruit production. Flowering is not immediate, nor is it dramatic, but it is essential, and signals that the plant has reached a level of maturity where it can begin the slow process of forming the tomato fruit. The first flower clusters usually appear between the 6th and 10th leaf node along the main stem, depending on the variety and the growing conditions. These clusters are called inflorescences, and they typically contain several small yellow flowers. Each flower is a complete reproductive structure containing both male and female parts that together make it possible for pollination and fruit development to occur. The yellow petals surround a central column that includes the stamens and the pistil. The stamens are the male parts of the flower, and they produce pollen, while the pistil is the female part, which contains the ovary that will eventually develop into a tomato. Pollination is the process by which pollen is transferred from the stamens to the pistil, allowing fertilization to take place. In tomatoes, this can happen through self-pollination, meaning that a single flower contains all the necessary structures to reproduce without relying on another flower. However, environmental factors play a significant role in successful pollination. In outdoor gardens, wind and movement help shake the flowers and distribute the pollen. In addition, insects such as bees also assist by visiting the flowers and vibrating their wings, which helps dislodge the pollen in a process known as buzz pollination. In indoor or greenhouse settings, where natural pollinators may be absent, growers often replicate this process by gently shaking the plants, using tools such as electric toothbrushes or tapping the flower stems by hand. Without this stimulation, pollen may not move effectively, resulting in poor fruit set or misshapen tomatoes. Once pollen reaches the pistil, it travels down a tube called the style into the ovary, where fertilization occurs. This triggers a transformation within the flower, as the ovary begins to enlarge and develop into a fruit. The petals usually fade and drop off shortly after pollination, and the energy of the plant is redirected from producing new leaves to supporting the growth of the developing tomato. During this period, the plant continues to require balanced conditions, especially in terms of temperature and humidity. If the air is too dry or too humid, pollen can become less viable. If temperatures are too high or too low, the flowers may drop before pollination occurs. Ideal temperatures for flowering and pollination range between 18 and 27 degrees Celsius. Within these parameters, the plant is most likely to successfully transition from flower to fruit. Some flowers may fail to pollinate, and these will typically wither and fall away without producing any visible fruit. This is a normal part of the process, as not every flower results in a tomato. The plant produces more flowers than it needs as a natural form of insurance against unfavorable conditions or pollination failure. The early flowers that form lower on the plant tend to produce the largest fruits, while later flowers are often smaller and may result in less uniform tomatoes, especially as the plant ages or faces environmental stress. The flowering stage is also a visual signal to growers that the plant is entering its reproductive cycle. It is often at this stage that nutrient requirement shifts slightly, with more emphasis placed on potassium and phosphorus, which support flower development and fruit growth. Excessive nitrogen during this period can result in lush, leafy growth, but reduced flowering. As the flowers open and close over the course of several days, each one carries the quiet possibility of becoming a tomato. The yellow blossoms stand in gentle contrast to the green foliage, and they offer a delicate beauty that precedes the formation of the fruit. Watching the process unfold requires patience. From the first appearance of a flower bud to the full development of a ripe tomato, several weeks may pass. But without this soft bloom, there can be no fruit. The act of flowering is both ordinary and miraculous, a silent shift that turns light air and time into potential food. It is here, in the calm center of the plant, that transformation begins. Again this time, with the aim of reproduction. Flowering is the moment where all previous growth converges, and all future fruit depends upon this quiet, successful exchange between structures that have evolved for just this task. In the story of the tomato, this stage may be overlooked, but it is vital and precise, a fleeting window of opportunity that makes the rest of the journey possible. And so, the plant flowers and waits. After successful pollination, the tomato plant begins a new phase of quiet transformation, one that unfolds slowly and steadily as the fertilized ovary of the flower begins its journey toward becoming a fruit. This process starts modestly with a swelling at the base of the flower, a small green bulge that gradually grows in size and weight over the course of days and weeks. This swelling is the earliest visible sign that a tomato is forming, and it represents the culmination of all the plant's previous efforts. As the fruit grows, the plant redirects its internal resources to support its development, drawing sugars from the leaves, water from the roots, and nutrients from the surrounding soil. The skin of the young tomato remains firm and green at first, thick enough to protect the inner tissues, yet permeable enough to allow for expansion. Inside the fruit, small chambers, called loculars, begin to fill with gel-like substance surrounding the developing seeds. These seeds are the result of the fertilized ovules, and they rest suspended in the pulp, each one carrying the full genetic code of the plant and the potential to become a new tomato in the next season. The outer layers of the tomato continue to enlarge and stretch as cells divide and expand. During this time, the fruit is vulnerable to pests, environmental stress, and disease. High winds or heavy rain can bruise the fruit, while inconsistent watering can cause cracking. The plant relies on steady conditions and careful attention to ensure that the fruit develops evenly and without interruption. The fruit remains green for most of this phase due to the presence of chlorophyll, the same pigment that gives leaves their green color and allows photosynthesis to occur. This green stage can last for several weeks, depending on the variety of tomato and the surrounding conditions. As the fruit matures, internal changes begin to occur that prepare it for the final stage of ripening. The texture of the flesh begins to soften, the internal structure becomes more defined, and the accumulation of sugars increases. This gradual shift sets the stage for the visible transformation that follows. Ripening is a complex and carefully regulated process that involves hormonal signals, particularly the increase in a plant hormone called ethylene. Ethylene acts as a trigger, initiating a series of chemical reactions that lead to the breakdown of chlorophyll, the formation of new pigments, and the softening of cell walls. As chlorophyll degrades, it is replaced by pigments such as lycopene and beta-carotene, which give tomatoes their characteristic red, orange, or yellow color. These pigments are antioxidants and contribute not only to the appearance, but also to the nutritional value of the fruit. The skin becomes thinner and more translucent, allowing the colors underneath to show through. The flesh becomes juicier and more flavorful as acids and sugars reach their peak balance. This change is not just aesthetic, it signals that the fruit is ready to be eaten or preserved. The timing of ripening is influenced by temperature, light, water, and the age of the fruit. Tomatoes ripen best between 20 and 25 degrees Celsius. Too much heat can slow down pigment development, while too little light can result in uneven coloration. During ripening, the plant may begin to reduce its energy investment in the fruit, signaling the end of its life cycle. Leaves near the fruit may yellow or die back, and new flower production may slow or stop altogether. The plant turns its focus to maturing the seeds and completing its reproductive cycle. In some cases, growers will harvest tomatoes just before full ripeness, allowing them to finish ripening off the vine to reduce the risk of damage or spoilage. Others prefer vine-ripened tomatoes for their fuller flavor and richer texture. Regardless of the method, the process of ripening marks the tomato's transition from a growing structure to a finished fruit ready for consumption. Throughout this entire stage, the tomato remains still on the vine, silently changing shape, color, and flavor. From a small green sphere to a full ripe fruit, this transformation is slow, steady, and deeply dependent on time. There is no shortcut to ripening, no substitute for the gradual unfolding of texture, taste, and color that occurs within the skin of the tomato. It is a process governed by biology, shaped by environment, and refined by countless generations of cultivation. In the life cycle of the tomato, this is the moment of fulfillment, the point at which the promise of the flower is realized in the weight and color of the fruit. It is a transformation that speaks not with sound, but with substance, not with speed, but with patience. The tomato ripens in its own time, held by the vine, nourished by the sun, and watched by those who wait to taste what it has become. After the tomato has fully developed and completed its gradual process of ripening, the moment of harvest approaches, not as an abrupt event, but as a continuation of the tomato's long and silent journey. The act of harvesting is deceptively simple, and yet deeply tied to timing, environmental observation, and intention. Determining the right time to harvest a tomato depends on many factors, including variety, climate intended use, and desired flavor profile. For most tomatoes, the ideal stage for harvest occurs when the fruit has reached full color, whether red, yellow, orange, or pink, depending on its type, and when it yields slightly to gentle pressure. At this point, the internal sugars have developed, the acids are balanced, and the flesh has achieved the desired juiciness and texture. In cooler climates where ripening may be slower, some growers choose to harvest tomatoes when they are partially colored, also known as the breaker stage. These tomatoes will continue to ripen off the vine, but must be handled carefully to avoid bruising or spoilage. On the other hand, vine-ripened tomatoes are often preferred for fresh eating because they continue to draw nutrients and flavor-enhancing compounds from the plant until the moment they are picked. Harvesting is best done during the cooler parts of the day, typically in the early morning or late afternoon, when the fruit is firmest and least stressed by heat. This minimizes moisture loss and preserves freshness. The harvesting technique itself is gentle and deliberate. Tomatoes should never be pulled or twisted from the vine, as this can damage both the fruit and the plant. Instead, the fruit is either snipped with clean scissors or pruners, or gently cupped and lifted until it separates naturally at the stem joint. Some tomato varieties have what is known as a jointed stem, with a visible knuckle where the fruit detaches easily, while others require cutting the stem cleanly to avoid tearing. Harvesting also includes an ongoing assessment of the entire plant. Lower fruits often ripen first and must be checked frequently, while upper fruits continue to develop. In a well-maintained tomato patch, harvesting is a repeated and regular activity spanning days or even weeks as the fruits ripen in succession. Each trip through the garden reveals subtle changes, a shift in color, a softening of texture, a deepening of aroma. Overripe tomatoes may crack or fall from the vine, while underripe ones lack the full flavor and softness that characterize a mature fruit. If the weather threatens with early frost, heavy rain, or disease pressure, some tomatoes may be harvested early and ripened indoors, using natural ethylene production. They are placed in paper bags or on warm windowsills, allowed to complete their final stage in a controlled environment. The harvest also varies depending on the purpose of the tomato. For sauces, pastes, and preservation, slightly overripe tomatoes with concentrated sugars are ideal, while for slicing or salad use, firmer, vine-ripened fruit is preferred. Commercial growers often harvest at the mature green stage to ensure firmness during shipping, with ripening induced afterward using artificial ethylene gas. However, this method can affect texture and flavor and is generally avoided by home gardeners who prioritize taste over transport. During harvesting, damaged or diseased fruits are removed to reduce spread and waste. These are often composted unless infected, in which case they are discarded. Gloves may be worn to protect both the harvester and the fruit, but bare hands are often sensitive enough to feel subtle differences in ripeness. The baskets or containers used for collecting must be shallow and lined to prevent bruising and piling. Once harvested tomatoes should be kept out of direct sunlight and stored at moderate temperatures. Refrigeration dulls flavor and alters texture, so room temperature is preferred for ripe tomatoes unless preservation is required. The harvested fruit can then be used immediately or processed further through drying, roasting, canning, or pureeing. But before any of these actions can be taken, the moment of harvest must occur, the quiet gesture of lifting a ripe tomato from its stem, ending its time on the plant and beginning its life as food. This act is both final and anticipatory, a pause between growth and use, between cultivation and consumption. The hand that harvests completes the cycle started with the seed transforming care into substance. It is an ancient ritual performed across gardens and generations in stillness and repetition. The tomato has arrived at this point through light and water, time and intention. And now it rests in the hand, ready for what comes next. Once the tomato is harvested, its life continues, not as a growing organism, but as a product that must be moved, handled, and preserved. This new stage requires a different kind of care. One focused not on growth, but on maintaining quality, minimizing damage, and ensuring that the tomato reaches its destination in usable condition. Transportation and storage are integral parts of the tomato's journey, especially for tomatoes that are destined for markets, kitchens, or processing facilities far from the place where they were picked. The first consideration in transportation is temperature. Tomatoes are sensitive to cold, but also to excessive heat. If stored or transported in conditions that are too cold, usually below 10 degrees Celsius, the fruit can suffer from chilling injury, which leads to internal browning, soft texture, and a loss of flavor. On the other hand, high temperatures can accelerate ripening and spoilage. The optimal temperature range for transporting ripe tomatoes is generally between 12 and 20 degrees Celsius. For green tomatoes, or those harvested at the breaker stage, slightly cooler conditions can help delay ripening during transit. Humidity is another factor. Tomatoes need moderate humidity, usually around 80 to 90%, to prevent dehydration and shriveling. Too much moisture can encourage mold growth and decay, while too little causes the fruit to lose water and become rubbery. Air circulation must be carefully managed to balance these needs, allowing moisture to escape while keeping the tomatoes cool and stable. The physical handling of tomatoes is a major determinant of quality after harvest. Because they bruise easily, they must be packed in shallow containers or trays that prevent stacking and crushing. Commercial operations often use specially designed crates with ventilation holes and padded interiors to reduce impact during movement. In smaller scale operations, tomatoes are typically picked into baskets or boxes lined with soft material and carried by hand to nearby storage areas or markets. Whether by truck cart or on foot, every bump and shift has the potential to mark or damage the fruit. In long-distance transportation, tomatoes are often loaded onto refrigerated trucks, also known as cold chain vehicles, which maintain steady temperature and humidity throughout the journey. These trucks may be divided into zones, allowing different stages of ripeness to be stored separately to avoid premature ripening or spoilage. The position of the fruit in the truck matters as well. Tomatoes placed near the engine or vents may experience temperature fluctuations, while those buried under heavier loads may suffer physical damage. In global trade, tomatoes may also travel by ship or plane. For international export, tomatoes are often picked at the mature green stage to withstand long transit times. Upon arrival, they may be treated with ethylene gas in ripening chambers to bring them to full color. This process is carefully timed and controlled to ensure that the tomatoes are visually appealing when they reach store shelves, though it may result in flavor differences compared to vine-ripened fruit. Once at their destination, tomatoes enter storage facilities where they await distribution. These facilities are often climate-controlled, with regular monitoring of temperature, humidity, and air composition. Some warehouses rotate stock to ensure that older tomatoes are sold first, reducing waste. Others may separate tomatoes by size, color, or variety, depending on their intended market. For example, cherry tomatoes are stored differently than beefsteak varieties due to their shape, density, and packaging needs. At the retail level, tomatoes are displayed in open bins or containers with enough airflow to keep them cool. They should not be stored in plastic bags, as this traps moisture and encourages mold. Shoppers may handle the fruit, which can introduce bruising or contamination, so frequent turnover and gentle handling are important. In home storage, tomatoes are best kept at room temperature, away from direct sunlight. Refrigeration is only recommended for very ripe tomatoes that need to be kept for more than a few days. Once refrigerated, the texture and taste may change, becoming mealy or muted. Some of these effects can be reduced by allowing the tomato to return to room temperature before eating. For those not immediately consumed, tomatoes can also be preserved through freezing, drying, canning, or fermenting. Each method requires specific preparation and storage conditions, but all begin with healthy, undamaged fruit. In every context, from harvest to table transportation and storage, serve the quiet purpose of extending the life of the tomato and protecting its flavor and structure. These steps are not glamorous, and they often go unnoticed, yet they are essential to the tomato's availability in distant markets, across seasons, and across continents. The tomato does not move by its own power. It is carried by systems and hands designed to preserve it. And in that careful movement from place to place, the final chapters of its journey begin to unfold. After the tomato has been harvested, transported, and stored, its transformation continues, not through growth, but through processing a series of methods and steps that turn the raw fruit into a variety of edible products. This stage of the tomato's life cycle does not involve the sun or the soil, but the quiet work of hands and machines, kitchens and factories, recipes and techniques that have developed over centuries. The processing of tomatoes begins with sorting and cleaning. Tomatoes are selected based on ripeness, firmness, and absence of blemishes. Damaged or overripe fruits are often excluded from processing lines that require visual uniformity. The selected tomatoes are then washed thoroughly using water sprays or agitation in tanks to remove dirt, pesticides, or residues. After cleaning, the tomatoes are often blanched, which involves briefly submerging them in hot water or passing them through steam tunnels. This loosens the skins, making them easier to remove, and also helps to preserve color and reduce bacterial load. After blanching, the tomatoes are peeled either manually or mechanically, depending on the scale of production. Some processing operations include the seeds and skins, while others discard them depending on the final product being made. For sauces, pastes, and purees, the tomatoes are crushed into pulp, using gentle pressure to preserve flavor and texture. The crushed pulp is then cooked slowly, allowing excess water to evaporate and flavors to concentrate. This cooking process thickens the mixture and develops the deep, rich taste associated with cooked tomato products. In large-scale processing facilities, this step is done using vacuum evaporators, which remove moisture at lower temperatures, preserving the natural sweetness and colour. For tomato paste, the pulp is concentrated to a thick consistency and packed in sterile containers for commercial or home use. For tomato sauce, additional ingredients are added such as salt, herbs, onions, or garlic. These additions are cooked with the pulp to create a consistent and flavorful sauce ready for use in cooking, or as a base for more complex dishes. Tomato juice is produced by blending the pulp with filtered water and straining the mixture to achieve a smooth, drinkable consistency. It may be seasoned with salt or other spices, depending on regional preferences. Diced tomatoes are prepared by cutting the peeled fruit into small cubes and sometimes packing them with tomato juice or puree. These are commonly used in soups, stews, and pasta dishes. Another form of tomato processing is drying. This can be done using sun-drying, traditional oven methods, or industrial dehydrators. Sun-dried tomatoes retain their sweetness and can be stored for long periods, often packed in oil with herbs for additional flavor. Drying reduces the moisture content to prevent spoilage while intensifying the natural sugars and acidity of the fruit. Canning is one of the oldest preservation methods for tomatoes. In this process, whole peeled tomatoes or processed tomato products are placed in sealed jars or cans, which are then heated to kill bacteria and create a vacuum seal. This allows tomatoes to be stored safely for months or even years without refrigeration. Fermentation is another method used in some cultures to preserve tomatoes. In this process, the fruit is submerged in a brine solution where beneficial bacteria convert sugars into acids. This not only preserves the tomatoes, but also creates a unique, tangy flavor that can be used in chutneys, pickles, and sauces. Freezing is a simple and effective method for preserving tomatoes at home. Whole or chopped tomatoes can be frozen raw or cooked and stored for later use. Freezing changes the texture of the tomato, making them better suited for cooked dishes than for fresh use. Each of these processing methods extends the life of the tomato and allows it to be enjoyed in different forms across seasons and distances. Processing transforms the tomato from a perishable item into a shelf-stable product, while also enhancing its usability in cooking. The choice of method depends on cultural preferences, available equipment, and intended flavor profiles. In many homes and kitchens, the process of turning tomatoes into sauce or paste is a seasonal tradition carried out during the summer harvest and preserved for use in winter. In factories, the same transformation is scaled up, with machines replicating the careful steps once done by hand. Despite the scale, the principles remain the same: heat time, cleanliness, and care. Processing does not diminish the tomato, but refines it. It captures the essence of the ripe fruit and preserves it in forms that are practical, versatile, and deeply rooted in culinary history. From raw fruit to thick paste, from juicy flesh to tangy sauce, the tomato changes, yet remains recognizably itself. Through these processes, the tomato becomes an ingredient, a flavor, a texture, and a memory. And so, its journey continues, not in the field, but in the pot, the jar, the plate, and the palate. Once the tomato has been grown, harvested, transported, and processed, it finds its way into kitchens across the world, where it takes on new identities, shaped by cultural traditions, local ingredients, and culinary techniques. The tomato is no longer just a fruit or a plant, but a medium through which people express history, memory, and flavor. In Italian cuisine, the tomato plays a central role, serving as the foundation of countless dishes, from the simplest pasta sauces to elaborate regional specialties. The basic tomato sauce, known as sugo or salsa di pomodoro, is made by gently cooking tomatoes with olive oil, garlic, and sometimes onions, allowing the natural sweetness and acidity to balance into a comforting base. This sauce becomes the heart of dishes such as spaghetti alla marinara, lasagna, and eggplant parmesan. In Naples, tomatoes are spread on pizza dough and baked into what is now one of the world's most iconic foods. The San Marzano variety, grown in volcanic soil near Mount Vesuvius, is prized for its low acidity, firm flesh, and sweet taste, making it a favorite for sauces and canning. In Spain, tomatoes are used in gazpacho, a cold soup made from blended tomatoes, peppers, cucumbers, and garlic, served chilled during hot summer months. Another Spanish dish, pan con tomate, involves rubbing fresh tomato onto crusty bread, sometimes with olive oil and salt, creating a simple yet deeply flavorful snack or breakfast. In France, tomatoes are featured in ratatouille, a vegetable stew from Provence that combines tomatoes with zucchini, eggplant peppers, and herbs to highlight the bounty of the Mediterranean. In North Africa, tomatoes are cooked into spicy stews such as shakshuka, where eggs are poached in a simmering sauce of tomatoes, chili peppers, and onions. This dish crosses borders, appearing in Israeli, Moroccan, Tunisian, and Turkish tables with slight variations. In the Middle East, tomatoes are both cooked and raw, often included in salads like tabbouleh or fattoush, where their brightness offsets herbs, bulgur, and citrus dressings. Tomatoes are also pureed into sauces, served over rice, or used in stuffed vegetable dishes, where tomatoes, peppers, and eggplants are filled with rice meat or lentils. In India, tomatoes are an essential ingredient in curries, dals, and chutneys. They provide the acidic base that balances the richness of spices and ghee. Tomato-based gravies are infused with cumin, coriander, turmeric, and garam masala, producing vibrant dishes like butter chicken or paneer tikka masala. In South India, tomatoes are used in rasam, a thin, spicy soup made with tamarind pepper and mustard seeds. In East Asia, the tomato appears less frequently, but with distinct purpose. In China, tomatoes are stir-fried with scrambled eggs in a dish that is both simple and beloved, a comfort food for many households. In Japan, tomatoes are often eaten raw in salads or juiced as a beverage. More recently, Western-style tomato sauces have become common in Japanese spaghetti dishes or used in fusion recipes. In Latin America, tomatoes are central to salsa, whether raw cooked, roasted, or blended with chilies, onions, and herbs. Salsa fresca, pico de gallo, and salsa roja all rely on tomatoes to provide body and acidity. In Mexico, tomatoes are used in moles, enchilada sauces, and pozole, a hominy-based soup with rich red broth. In the United States, the tomato is ubiquitous, appearing in ketchup, barbecue sauces, sandwiches, salads, and pasta. Regional dishes, such as fried green tomatoes in the American South or tomato pie in the northeast highlight the fruit's versatility. Heirloom tomatoes are celebrated in summer with minimal seasoning, allowing their natural flavor to shine. In Eastern Europe, tomatoes are used in hearty stews such as goulash, or in preserved forms like tomato paste or juice for winter use. In Russia and Ukraine, pickled green tomatoes are a common delicacy preserved in brine with garlic and herbs. Tomatoes also appear in borscht, complementing beets and cabbage with their acidity. Across Africa, tomatoes are blended with onions and peppers into sauces that serve as a base for stews and rice dishes. In West Africa, tomato and peanut stew is a rich, savory dish combining tomatoes with ground nuts, creating a deep, flavorful sauce served with fufu or rice. In Ethiopia, tomatoes contribute to lentil dishes or spiced sauces served with injera, the fermented flatbread. Despite cultural differences, the tomato serves a similar purpose in all of these cuisines. It adds moisture, acidity, depth, and color. It enhances spices, balances richness, and provides structure to countless recipes. The tomato adapts not only to soil and climate, but to culture and taste. Its flesh holds the memory of summer sun, and its juice carries the flavor of generations. In every form, it is transformed by technique, tradition, and time. Whether sliced raw or simmered for hours, the tomato is always part of something larger. It does not dominate, but supports. It does not shout, but sustains. It is a quiet constant on tables around the world, a fruit that has become essential, not through rarity, but through reliability. The culinary journey of the tomato is vast and ever-evolving, shaped by people who continue to discover new ways to cook, serve, and savor it. The story of the tomato begins in silence beneath the surface of the soil, where a single seed waits, surrounded by moisture, warmth, and the slow workings of time. From this tiny vessel of life, a sprout emerges, reaching for light and anchoring into earth, a process that unfolds without noise or urgency, guided only by nature's rhythm and the invisible instructions encoded within the seed. As days pass, the sprout becomes a seedling. The seedling becomes a plant, and the plant extends its branches outward, forming leaves, stems, and tiny yellow flowers. Each stage arrives gradually marked by the sun's arc and the changing feel of the air. Growth is steady, not sudden, and within this constancy, the tomato plant prepares to complete its purpose. The flowers invite pollinators to brush their delicate parts, transferring pollen from stamen to stigma and allowing fertilization to occur. What follows is transformation, not of sound, but of shape, as the fertilized ovary becomes a fruit, beginning as a green swelling behind each bloom. This small fruit grows in size, nourished by roots that gather water and nutrients, and by leaves that catch light and turn it into energy. Inside, the fruit seeds develop suspended in gel, awaiting their own chance to begin again. The fruit matures, changing color, softening in texture, and deepening in flavor. It does not rush this process. Ripening arrives through temperature light and time through the invisible action of hormones and the slow breaking down of structure and pigment. The green fades, the red emerges, and the tomato announces its readiness, not with sound, but with stillness. The harvest is a human act, a moment of contact between hand and fruit, where the cycle of growth ends and the cycle of use begins. Tomatoes are picked with care, sorted gently, and transported thoughtfully. Their fragile skins require quiet handling. Their flesh yields to pressure. Their lives, post-harvest, depend on conditions that preserve rather than stress. In homes and factories, tomatoes are washed, peeled, chopped, blended, simmered, or preserved through countless methods, both ancient and modern. Their forms multiply into sauce, paste, juice, diced, flesh, dried slices, and rich purees. Through these transformations, the tomato enters kitchens around the world, becoming part of recipes that stretch across continents and centuries. From Italy to India, from Mexico to Morocco, the tomato absorbs the flavors of garlic, basil, cumin, or chili. It rests atop dough simmers in stew fills, jars for winter, and sits raw on plates in warm summer kitchens. In each dish, it does not command, but support, enhancing and extending the other ingredients with quiet acidity and gentle sweetness. The tomato has become more than a fruit. It is a presence in memory, in culture, in taste. It is part of the vocabulary of cooking, part of the history of migration, trade, and adaptation. Its journey from seed to plate connects hands and minds across space and time. In every step of its life cycle, the tomato requires patience. It grows slowly, ripens gently, travels carefully, and transforms completely. It is not a spectacle, but a companion in the background of meals, in the corners of gardens, in the quiet acts of planting, harvesting, cooking, and eating. Its life cycle is not only biological, but cultural. Its story belongs to soil, but also to storybooks, to traditions and tables, to harvest festivals and family recipes. It moves from garden to kitchen without fanfare, and yet it is everywhere once you begin to notice it. As we reach the end of this journey, the tomato stands not just as a fruit, but as a symbol of cycles, continuity, and care. It is a reminder that nourishment begins long before the moment of eating and continues long after the plate is cleared. It begins in stillness, grows in silence, and ends in presence. The tomato's story is not loud or brief. It is slow, enduring, and complete. From seed to sauce, from garden to plate, it invites us to move at the pace of nature, to find comfort in repetition, and to see beauty in the ordinary. And in this quiet tale, we find not just food, but rhythm, connection, and peace.